Welcome to functions. Functions are simply a different way of thinking about our relationships we've already been dealing with. In this case, I have a linear equation here. I have C equals 25t plus 75, where C represents the cost in dollars of a repair, depending on the number of hours it took to complete the repair. So this is the definition of this relationship right here. We have as a table of values and then a graphical representation of the same thing. This is a linear relationship. The 25 is the slope, the 75 is the y-intercept, stuff that you've seen and feel very comfortable with. Let's now write this as a function. And it's a simple, visually a simple thing, but the ramifications of it are quite big. So I'm just going to write c of t. What I'm doing here is I've now declared the variable dependence in this relationship. What this notation means, and first of all to say this does not mean c times t. It's really, really important. Let's look at this. If I write c of t, what this means, it means c, or the value of c, depends on the value of t. Or in other words, this is a mathematical machine now, this over here, in which we input values of t and we get output values of c or c of t. Or in other words, this is a mathematical machine where we input different times it takes to make a repair and it outputs values. We call the inputs independent variables and we call the outputs dependent variables because the value of the output, or the cost in this case, depends on the number of hours we plug in. So here's what we do. What we want to do, we'll take this function and let's say we want to plug in t equals 4, let's say, for instance. This would represent finding the cost when t equals 4. If to do this, what we write in function notation is c of 4. What this represents is that we want to input the value of 4 into our function above, our mathematical machine. And so we would do that. We just write 25 times 4 plus 75. What we get out from this is c of 4 equals 175. Again, the important thing to get from this is this notation is this means if we input a 4, we output a 175. Again, just to hit this again, this notation over here, c comma 4, does not mean c times 4. There's no multiplication going on in this case. What this just means is that we want to input a value of 4 for t. If you notice back up here to this original notation, what we've done is just taken out this t value and we've put a 4 in its place, is what we're showing down here. And to find that, we just plug in 4 for the t value here. Very important. Okay, so this statement right here in function notation is exactly the same thing as this line in a table of values, and exactly the same thing as this point graphically being represented right there. Along the x-axis, we're going to be tracking inputs, and along the y-axis, we're tracking outputs. Again, mathematically, everything you've done before is still completely legit. We just have this dependence relationship and this notation that looks right here. Let's think about some different questions that could be asked given the data that we're given. Again, the first thing you'd be responsible for is just getting used to this notation. Someone could ask us something like, let's see, find c of 2 could be a question that's being asked. Well, to find c of 2, we could just plug 2 back into this original function for t, or what we could do, if we had a table of values, we could find it right here. Right here, we're being told that when t is 2, c, or let's actually write that dependence here too, c of t is 125. This line right here tells us that c of 2 is 125. Or in other words, if we input an hour or a value of 2 for t, we're outputting 125. A very similar question is that someone could ask us, hey, when is c of t equal to 225? Well, we can find this in a couple different ways. One way would be, again, to look at this table. This table right here is the line or the row when c equals 225. If we look at that, that's related to the value of t equals 6. So c of t equals 225 when t equals 6. Another thing that we could be asked is we could be asked graphically, hey, when is c of t equal to 100? Well, we could do that here on this graph. What we need to do is find out, again, this is the output. We're looking for the input. When the output is 100, what is the input? We simply would go to the graph, find 100 on our output axis, go across to this point right here, and we're just looking for the input value. And in this case, the input would be 1. So c of t equals 100 when we plug in t equals 1. Again, this is just meant to be a very, very quick introduction to this notation and the different ways you'll be asked to represent that. Functions can be represented by equations, as up above, up here. They can be represented by table of values here, or they can be represented graphically, like in this case right here. Each of those are describing the same types of information, and you should be able to solve function questions given either of those three pieces of information.